Hey guys, welcome back to Kolbenkraft. In today's video, we are going to talk about suspension system. Now, a basic suspension system comprises of a coil spring and a damper. Coil spring will, absorb the shocks that a vehicle receives because of the unevenness of the road surface. For example, when a vehicle runs into a pit or a bump, we all know that, whereas a damper will just dampen the oscillations that the coil spring is having. But now, whenever we talk about suspension system, in particular, whenever we talk about the spring coils, there is a term which is often used, which is known as spring constant. Now, spring constant is basically dependent on four main factors. The first factor is the shear modulus. Shear modulus is basically the ratio of shear stress and the shear strain. The next we have the diameter of the spring wire. Constant is also dependent on the diameter of the coil and also the number of windings. So basically this is the formula for the spring constant over here. And now comes the important part. If this spring constant is too high, then the vehicle will be able to take turns properly. In other words, the stability of the vehicle will increase during the cornering when the stiffness is high. But then on the contrary, the when a vehicle will go through a bump or a pit, the passenger comfort will not be that high because the spring will become very stiff and it won't be able to absorb the shocks that effectively. On the other hand, if we lower the stiffness, then the opposite will happen. That is, the passenger comfort will be high, the spring will be able to absorb the shocks very effectively, but during the cornering, there'll be a lot of instability. So when we talk about commercial vehicles, there's always a compromise between the ride quality and the handling quality. When the this constant is stiff, that is the spring constant is high and the springs are stiff, then we are talking about the handling quality. And if it's low, that is if the vehicle is more towards the passenger comfort, then we are talking about the ride quality. If we take Formula One vehicles as an example, Formula One vehicles are designed to have high stability during the cornering. We all know that they take turns at 100 kilometer per hour or 150 kilometer per hour. Still, they do not have that the rolling moment is not that high. In other words, the stability is very much maintained. So at then we can say that the stiffness, the handling quality of the vehicle is high, and the reason behind this is this spring constant is high, the spring is stiff over there. But if the same vehicle will go through a bump, then it won't be able to absorb the shocks that effectively. So coming back to commercial vehicles, there's always a compromise between the ride quality and the handling quality, and that in keeping in mind these factors, keeping in mind the type of the vehicles, this spring constant is determined. Now, every spring comes with a type of specification. There are three numbers which are mentioned on them. For example, over here, we have 70, 170, and 60. So, let us first talk about 70. 70 defines the spring constant over here, which is given in kilogram per centimeter. So, here we can say that for 70 kilogram of the force, there'll be a deformation of 1 centimeter. And now talking about 170, that is the length of unloaded spring. That is, there is no force acting on the spring. The spring is in unloaded form, then it will be 170 mm. This dimension over here is in millimeters. And the last is 60, which is the diameter of the spring wire, which is also given in mm. So this was all about the spring stiffness and how it affects the ride quality and the handling quality, how it affects the comfort of the passengers and so on. So this was all for the video. I'll see you guys in the next one.